Assalamualaikum dan hi. How are you doing? I hope all of you are in a good condition and happy. Before we proceed to our discussion topic, I want to wish Selamat Hari Raya Aidilfitri. Maaf Zahir dan Batin. Today, I would like to talk about stack in data structure. Let's start our lesson today. Initially, I will start with explaining the introduction of stack. Right after that, I will brief about the implementation of stack using Java. A stack is an unordered collection of items where the addition of new item and the removal of existing items always take place at the same end. This end is commonly referred to the top, and the opposite end is known as the base. This situation is called LIFO, last in, first out, or FILO, first in, first out. Items that are closer to the base have been in the stack the longest. The most recently added items is always on the top of the stack and thus will be removed first. The stack provides an ordering based on length of time in the collection. The age of any given item increases as they move from top to base. There are many examples of stacks in everyday situation. Consider a stack of plates on a table, where it's only possible to add or remove plates to or from the top. Or imagine a stack of books on a desk. The only books whose cover is visible is the one on top. To access the others, we must first remove the ones sitting on the top of them. Stack is a linear data structure which follow a particular order in which the operations are performed. Mainly, the following four basic operations are performed in the stack. Firstly, push. The push operation adds an item in the stack. The new item will be added at top of stack. The second operation is pop. The pop operation removes an item from the stack. The items are popped in the reverse order in which they are pushed. It means the item is removed from top of stack. The third operation is pick or top. This operation is to return top element of stack. And lastly is empty operation. This operation returns true if stack is empty, else it will return false. This diagram shows that the example of stack operation that involving push and pop. As we can see, the new item, initially there are no item in the stack, and the new item, which is B, is coming, and it push into the stack, and the B will place at the base of the stack. Right after that, the incoming item is A, and A is pushed into the stack, and A will place at the top of the B. Next operation is pop. It will pop the top of item. The current top item is A, and A will be popped out or removed from the stack. And lastly, the new incoming item is C, and the C will be placed at the top of B. And as we can see here, B always stay at the base, and it will stay the longest amongst the others values or items. In computer science, there are many stack applications. Some of the application of stacks are reverse a string, undo features in software, check for balance parentheses in an expression, involved in arithmetic expression operation. Okay, the reverse string, a string. To reverse a string, we simply push letter by letter into the stack. The letters will fill at the base first, and the incoming letter will fill at the higher stack. Letter pop the letters. The letter at the top stack will be removed first and followed by the corresponding letters until the last. Finally, we get the reverse string. Okay, secondly, undo features in software. Most of the software is ready with undo features. Actually, every operation that has been done will be stored into a stack. When it is requested to undo, the last operation that was stored will return. Okay, next, check the for balance parenthesis in expression. The compilers of programming language also utilize stack in order to check opening and closing parentheses in an expression. If the compiler found the opening bracket, it will push into stack. It will find the closing bracket. If the compiler found the opening bracket, it will push into the stack. Otherwise, if it find the closing bracket, it will check if the top of stack is the same kind or not. And lastly, involved with in arithmetic expression operation. If some of operation that involved with arithmetic expression are conversion from infix to postfix expression, conversion from infix to prefix expression, and lastly, evaluation of postfix expression. These three operations that related to arithmetic expression will be explained in detail later. Hello. Okay, for this round I will be explaining the implementation of stack. Previously already learned about the basic of the stack or the concept of stack. Okay, now we are going to walk through how to implement stack using Java. Actually, in Java we can implement a stack using list. We can develop a list using two types of lists in Java, which are sequential list and linked list. Okay, so in order to develop a stack application, we can implement it using through both of the linked list or sequential list. Why we can use linked list or sequential list in order to implement stack? Okay, as we look at the structure of the stack, okay, actually the structure of stack is we can represent this stack vertically. Okay, the stack will arrange the item vertically, and the first item will place at the base, and the second item will place at the top of the base item, and if the new incoming item will be placed at the, it means it will always place at the top when it insert a new item. When it comes to remove the item, we will get the first or top of the item in the stack will be removed first, or in the terms in the stack, we call it as pop, and for the remove, and push for the insert. Okay, so we can map between the structure of the stack with the list. Okay, as we okay, how to map both of the structure. So the top of the stack we can map with the front of the list, while the base of the stack we can map with the end of the list. Okay, that's why we can implement stack using list. Okay, in the Java we can implement the list using a sequential list or a linked list. Okay. Okay, stack can be implemented using linked list or sequential list. Okay. So in order to develop ADT version or stack ADT, we need to self define class stack. Okay. That use for this version we will use a linked list. Okay. New node can be add and remove uh, to or from stack only at the top or front list. So the both operation push and pop actually involve happen at front only, okay, or at top of the stack. Okay, so it's quite simple actually. Reference link of the last node is in stack is set to null to indicate the bottom of the stack. Okay. Start using linked list structure. Dynamic data structure element are stored anywhere in memory. Okay, this is the demonstration about how we push and pop into from the stack. Okay, let's look the implementation using this data structure. Okay, a push operation will call insert at front. Okay, so in the linked list already have the method that we can access or insert at the new item at the front. It called insert at front. So we can use just to implement a push operation. We just call insert at front. Okay. Meanwhile, for the pop operation, pop is an operation that we want to remove the item at the top. So we can call remove from front, okay, in the linked list. Okay, we did not do not need to uh, develop new method for both of the operation push and pop. Meanwhile, pick operation. Pick mean we want to access or we want to get the top of item in the stack. Okay, in order to get the first item in the list, we can get through get first method. This method also already defined in the linked list. So it's yeah, it is very easy, to implement a stack using a linked list. Okay, look at the class definition for the linked list. Okay, so in order to implement stack, we need one linked list class. Okay, we can use linked list class definition that we have learned before. So in the linked list class, what we have, we need to access the method. Only a few methods involved, such as is empty, insert front, remove from front, and get first. Okay, okay, let's look the class stack. Okay, so in the class stack, we need to define the class stack. The class stack needs to extend linked list class, which means it inherits from a linked list class. Okay, so the stack class is very simple. Consists of constructor, push, method, pop, pick, and is empty. So the push object actually we can define the definition is just to call insert front in the linked list class. Okay, meanwhile for the pop, we just uh, call method remove from front in the linked list class. Okay, so the difference between push and pop is the push we just to insert the data and without return the value. Meanwhile for the pop we need to return the value because we want to remove the item, then we want to hold the value, the remove value. Okay, so we can do something lah on the value before we completely remove the value. Another one is pick. Okay, pick we can simply call method get first. Okay, in order to get the first item in the stack or on the top of stack. Okay, for example, how to implement a stack. Okay, firstly we need to declare object of stack. For example, stack 1. Okay, we have the one object of stack 1. So we can insert the data. To insert the data, we call method push. Okay, for example, Clayton, to insert Clayton into the stack, and insert a second item into stack is Eric. Okay, in order to get the item, we need to use pop method. Okay, for example, to display the top of the item. Okay, we just simply call pop stack1.pop. Okay, there's example. Okay, here we have one stack object. Okay, S1. So firstly we insert the item in the object S1. Okay, S1.push with the number 10. So the first item will be placed at the base of the stack. Okay. So the second item will be placed at the top of number 10, and as well as 12 and 13, and then it will arrange in 13, 12, 11, and 10 sequence. Okay, next assist to display the top element in stack. We can access through pick method. Pick method, as we see before, this method will return the top item. So the top item, current top item is 13. So it will display 13. Okay, next statement, pop. Okay, pop means we want to remove the top item. So the top item is, current top item is 13. So 13 will be removed. Okay, next, system.out print data in stack. Then loop the structure. Then so in order to access all the item in the list in the stack, we can do in a loop. So we can utilize is empty in order to check whether the stack is empty or not. So it will repeat the process, repeat until the last element in the stack. Okay, so now there are only 3 value in the stack, because the first the top values 13 already pop just now, and now the current top is 12. So it will get pop from the top. So firstly it will pop and display 12, 11, and 10. Okay, I think it's very easy to implement a stack. Okay, next, advantages of stack. Okay, here are some of advantages of stack. Stack are widely used in compiler and operating system. Stack are used to generate machine language code for arithmetic expression to check parentage calibrations. Okay, I think these advantages or application of stack already mentioned in several. I give several application that we use in stack. So here is the more example. Okay, stack are widely used in compiler operating system. Stack are used to generate machine language code for arithmetic expression to check pair of parentheses. This example I already explained before. Stack are also used to solve complex arithmetic problems. Okay. Okay. For example, to convert infix expression to post or prefix notation. Okay. Okay. This problem will be explained in detail later. Maybe next video. Stack support recursive call of a method in the same manner as they do a conventional non-recursive method call. Okay, so we can implement a stack using recursive call. For your information, recursive method is method that it call itself. Okay, it will call itself until certain condition. So this stack is suitable to call the method stack method recursively because it can repeat until the last element in the stack. That's why it suitable use for stack. Okay, so I think for this video I already cover the introduction of stack and stack implementation using Java. Okay, so I hope you can understand the concept of stack and try to implement stack using Java, which are we can implement it using a sequential list or linked list. Okay. Hopefully you can try by yourself in order to experiencing how to implement stack using Java. Okay, in the next video I will be explain the application stack focusing on arithmetic expression conversion from infix notation to postfix and prefix notation. Okay, another one is how to evaluate the postfix expression using stack. Okay, so that's all for now. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.